Is sine 2 theta over cos 2 theta. So in reality, I'm trying to end up with 1 plus sine 2 theta over cos. Alright, this is sec 2 theta plus sine 2 theta. So this is my end result I'm trying to get to. 1 plus sine 2 theta over cos 2 theta. Alright, so I notice that I need to, this is what I'll be working towards. I'm working towards getting cos 2 theta in my denominator. So all of this should simplify to be cos 2 theta in the denominator. So let's get it. All right, so let's see how we can simplify this best. So typically we want to start with our left-hand side. Now we're going to substitute in the identity for sine 2 theta. Sine 2 theta is 2 sine theta cos theta. That's sine 2 theta, 2 sine theta times the cosine of theta. And then we want to plug in the identity for cos 2 theta. Identity for cos 2 theta is, well, there's 3 identity, but I'm going to use 1 minus 2 sine squared. You might wonder why. I'm using this one because I just want sine in the numerator to be dominant and cos in the denominator to be dominant, if that makes sense. So I'm going to use 1 minus 2 sine squared. As for cos 2 theta plus 1. So in the denominator now, what I'm going to have is cos 2 theta. Cos 2 theta is 2 cos square theta minus 1. As I said, I'm going to use this identity because I want sine to be dominant in the numerator and cos to be dominant in the denominator. So 2 cos square theta minus 1 plus sine 2 theta is 2 sine theta cos theta. Two sine theta cos theta. And then I have minus 1 right here. So I put like a minus 1. Now I'm going to simplify the numerator. So this is now equivalent to, now when I expand the numerator here, minus 1 plus 1 going to cancel. And minus 2 become plus. So in the numerator, what I'm going to be left with is 2 sine theta cos theta plus 2 sine square theta. I have now plus 2 sine square theta. No real issues. Nice. Plus 2 sine square theta. And then all of this is of course being divided by 2 cos square theta minus 1 plus 2 sine theta cos theta minus 1. No, all of this is just minus 1 and minus 1 make it become minus 2 here. Right? And so this is just 2 cos square theta. This is 2 cos square theta plus 2 sine theta cos theta minus 2. So what I'm going to do now is I'm just going to, I notice that there's so many 2's. I notice there's a 2 here, a 2 here, a 2 here, a 2 here, and a 2 here. So I'm just going to divide through the expression by 2. I'm going to divide through the expression by 2. I'm going to divide the numerator and the denominator by 2. I don't like seeing so many 2's. So I'm going to divide both the numerator and the denominator by 2. Just going to get rid of those 2. Getting rid of the 2's, numerator is going to just leave me back with sine theta cos theta plus sine square theta. That's what I'm left with, sine theta cos theta plus sine square theta. Then in the denominator now, what I'm going to do is, divide through by 2 as well. So now I just have cos square cos square theta plus sine theta cos theta. Now remember my objective. My objective is to generate this denominator. So I need to figure out how am I going to generate that denominator from this position. Now, one thing I notice is that I see a -1 here, but I know that 1 is sine squared theta plus cos squared theta. So I'm going to replace 1 with sine squared theta over cos squared theta so that everything is in terms of sine and cos. So this becomes equivalent to, in the numerator, I'm going to factor out sine theta. So I factor out sine theta from the numerator, and what I'm left back with is cos theta plus sine theta. And then in the denominator, as I said, I'm going to change 1 to sine squared theta plus cos squared theta. So in the denominator, it's going to become cos squared theta plus sine theta cos theta and then that 1, when I change the 1 to sine squared plus cos squared, it's going to just become minus sine squared minus cos squared minus sine squared theta minus cos squared theta, because it's -1 in it. It's really -1, so it's minus cos squared. All right. Now let's see what we have now. Now we have cos square. We have cos square and minus cos square. Cos square and minus cos square, these two cancel each other. Cos square theta cancels minus cos square theta. Good. So we're just left back with these two. So we're nice now. We're almost done. So what we end up getting now is, this is now equivalent to sine theta into cos theta, sine theta into cos theta plus sine theta. And this is now being divided by, going back around here, as you can see, we have now sine theta cos theta minus sine square. Both of these two have sine theta in common. So I'm going to factor out a sine theta. So while I factor out a sine theta, let me see what's going to happen. When I factor out sine theta, I'm going to be left back with, going around here, going to be cos theta minus sine theta. So I'm left back with cos theta minus sine theta. Alright, and so the sine theta is going to cancel the sine theta. And so this is what we're left with. Now you might say, so sir, how are we going to generate cos square? Good. Now remember, cos square is cos 2 theta. This is what we want to get in the denominator. We want to get cos 2 theta. But cos 2 theta is equal to cos square theta minus sine square theta. So what we're going to do to get that now is we're going to multiply this now by the conjugate of the denominator, which is cos theta plus sine theta. So we're going to multiply by cos theta plus sine theta. We're going to multiply the numerator and the denominator by cos theta plus sine theta. When you multiply the numerator by cos theta plus sine theta, you notice that it's going to be a square in the numerator and the difference of 2 square in the denominator. So it's a perfect square in the numerator. So it's going to become cos theta times cos theta is cos square theta. And then you're going to have cos theta times sine theta is sine theta cos theta. Sine theta times cos theta is sine theta cos theta. So that is just plus 2 sine theta cos theta. And then you're going to have sine theta times sine theta, which is sine square theta. Good. And then in the denominator, it becomes the difference of 2 square cos theta minus sine theta times cos theta plus sine theta. That's the difference of 2 square, so it becomes cos square theta minus sine square theta. So now we're good. Now what we notice is that cos square plus sine square is equal to 1. That becomes equal to 1. Then sine 2 theta is 2 sine theta, cos theta is sine 2 theta. And cos square minus sine square is cos 2 theta. So done. Because we can then just separate this now as 2 separate fractions as 1 over cos 2 theta cos 2 theta when we sec 2 theta plus sine 2 theta over cos 2 theta. And we're done now. We've pretty much finished. So that's 8 marks, nice and easy. As 1 over cos 2 theta, you can tell them that now is sec. And then sine 2 theta over cos 2 theta is tan. And so finally we complete the proof. Tan 2 theta. That's your right hand side. Nice and easy. Soft. That's your right hand side. Nice. So we completed the proof now. We have it, that's the proof. All right. We may continue. It says hence meaning using this result right here, we can solve that result equal to 0. So I'm going to go with hence. So going with hence, I'm going to be using this result that I got, sec 2 theta plus tan 2 theta equals 0. And instead of saying sec 2 theta plus tan 2 theta equals 0, I'm just going to go to this one. 1 plus sine 2 theta over cos 2 theta equals 0. So hence, that implies, because it says hence, it implies that we can solve 1 plus sine 2 theta over cos 2 theta is equal to 0. And if something is equal to 0, then I count the denominator 0. I must the numerator 0. So that implies that we're solving the numerator 1 plus sine 2 theta. It must be that part being 0. And if this is what we're solving being equal to 0, then all we need to do is bring over the 1. So we're solving sine 2 theta equal to negative 1. So if you're solving sine 2 theta equal negative 1, next thing to do is draw your circle. Just get out your little circle. It's always good to put the circle there. And then you need to look at which quadrant is sine 2 theta negative. I know that sine is positive in the first and the second quadrant. So these are not what we want this time. We want where it's negative. It's negative in the third and the fourth quadrant. Now, first thing is find the principal acute angle in the first quadrant, which is sine inverse of 1. Sine inverse of 1 is 90 pi by 2. That's the angle in the first quadrant. So the angle in the third quadrant is going to be pi plus pi by 2. Pi plus pi by 2. And the angle in the third quadrant is going to be 2 pi minus pi by 2. Those are the angles in the quadrants, 2 pi minus pi by 2. They didn't give me degrees or radians, and so I'm going to stick to radians. Pi plus pi by 2 is 3 pi by 2. And 2 pi minus pi by 2 is, that is, the multiply of this, that's what? Multiply up to, I'm getting 4 pi, still 3 pi by 2. So the same angle is in the third and the fourth quadrant. So the general solution is going to be equal to 3 pi by 2 plus 2n pi, where n is the amount of time you go around the circle. So that's the general solution. Nice and easy, soft. Easy 5 marks. Moving right along. It says, given that the cosine of A is equal to 3 over 5, and the sine of B is 3 over 4, calculate sine 2A. Now, I always like to just picture a little triangle. So you have the angle A, and they tell us that 3 over 5 is cos A, and so the adjacent is 3, the hypotenuse is 5, and so this is a 3, 4, 5 triangle, and so the opposite must be 4. Then sine B, meaning you have another triangle like this, and the angle is B, and they tell us that the opposite is 3, the hypotenuse is 4, so the adjacent is going to be, using Pythagoras theorem, it is 4 square minus 3 square all square rooted. 4 square minus 3 square rooted. Let me write that a little better. So 4 square minus 3 square all square rooted. So the adjacent is going to be 16 minus 9. That's 7. So the adjacent is the square root of 7. So what's sine 2A? Sine 2A, we have to remember, sine 2A is equal to 2 sine A cos A. That's the easiest formula to remember. Sine 2A is 2 sine A times the cosine of A. And so sine 2A works out to be 2 times, what is sine A? Sine A would be opposite 4 over 5. So sine A is 4 over 5 times the cosine of A, and the cosine of A is 3 over 5. Nice and easy, soft. So you go ahead and you work these out now. So 2 times 4 is 8. 8 times 3, 24. So sine 2A is 24 over 25. No issues with this question. 24 over 25. Nice. Now here, you're asking us, so what is cos A plus B? Cos A plus B, we have to remember that this is the compound angle formula. Cos A plus B is cos A cos B minus sine A sine B. Once you remember this formula, cos A cos B minus sine A sine B, we're good to go. Cos A cos B minus sine A sine B. So that's going to be equal to cos A cos B. Cos A is 3 over 5. Cos B from this triangle, cos B will be adjacent over hypotenuse, which is adjacent is root 7 over 4. So cos A, 3 over 5. Cos B, root 7 over 4. Minus sine A sine B. Sine A will go over to this triangle again. Sine A is opposite over hypotenuse, which is 4 over 5. Minus sine B. What is sine B? Sine B is, we'll go over to this triangle. Sine B is opposite over hypotenuse, which is 3 over 4. You may proceed to simplify your answer now. This is 3 root 7 over 20. I'm just going to write it as one fraction. 3 root 7. 3 root 7. 4 times 3 is 12. So 3 root 7 minus 12 over 20. That's 3 root 7 minus 12 over 20. Nice and easy, soft. Okay, so we finished that question. Now finally, this part of the question says, solve the equation sine theta. Is that a minus? Let's look. Yeah, that's minus. Solve the question sine theta minus root 3 cos theta equal 1. Once you're given these trig equations, the first thing to do is divide through by either sine or cos. I'm going to divide through by cos theta. If I divide through by cos theta, then sine theta over cos theta gives me tan theta. Let me see, tan theta. Alright, let's not do it this way. I'm not going to do it this way. Alright, first thing I'm going to do is I'm going to rewrite it in the r cos form. When it's equal to 0, it's easier to do that. I'm going to write it in the r cos form. In the r cos form, r would be equal to 1 square plus root 3 square, which is just 3 all square rooted. And so r is equal to, it just feels easier for me. Of course, you may have solved it differently. This is 2. Then I find my alpha. Alpha is tan inverse b over a. And so it's going to be tan inverse of minus root 3. Tan inverse of minus root 3. We work that out and we're getting, put that in a calculator, tan inverse of minus root 3. I'm getting minus pi by 3. And so to put it in the r sine form, I can rewrite this side as 2 times the sine of theta is 2 times the sine of theta minus alpha, and alpha is minus pi by 3, so it's going to become minus and minus become plus. So it's theta plus pi by 3, and that's equal to 1. So then I divide through by 2 to get that the sine. I get the sine of theta plus pi by 3 is equal to 1 divided by 2. And 1 divided by 2 is a half. So now this is what I'm solving. I'm solving the sine of theta plus pi by 3 equal to a half. As I always say, the next thing to do is draw your circle. You need where cos is positive. So you draw a little circle somewhere. You want where cos is positive. You cut your circle in 4 little quadrants. And cos sine is positive in the first and in the second quadrant. And so now you take sine inverse of a half. Sine inverse of a half will give you the angle in the first quadrant. So sine inverse of a half to find your principal acute angle, and that is pi by 6. You're going to get pi by 6. So the angle in the second quadrant is going to be pi minus pi by 6. And so that is what's going to give you your possible solutions for this. So that implies that theta plus pi by 3 is equal to pi by 6. Theta plus pi by 3 is equal to pi by 6. That's one possibility. This should have been pi by 3. So theta plus pi by 3 is equal to pi by 6. That's one possibility. Or the other possibility is that theta plus pi by 3 is equal to pi minus pi by 6. And pi minus pi by 6, this part simplifies to be 5 pi by 6. 5 pi divided by 6. That's what we're getting. Nice. So moving right along. So all we need to do now is subtract pi by 3 from both sides. And so we're going to get theta is equal to pi by 6 minus pi by 3. That is going to be pi by 6 minus pi by 3. All right, let me work that out in my calculator. Pi by 6 divided by pi by 3. Pi by 6 minus pi by 3. Pi by 6 minus pi by 3. And I get minus pi by 6. Minus pi by 6. So that's one possible answer for theta, minus pi by 6. Or the next answer is 5 pi by 6 minus pi by 3. So 5 pi by 6 minus pi by 3. And I get pi by 2. This one is giving me pi by 2. So theta equal minus pi by 6, or theta equal pi by 2. Those are the answers. If you don't believe it, you can check it out. Check it. Pi by 2 is 90 degrees. So put in a calculator sine 90 minus root 3 times the cos of 90. The cos of 90 is 0. So it's 1 minus 0, which is 0. 1 minus 0, which is 1, sorry. And you can check the other one as well, which is minus pi by 6. I guarantee you get it. Okay, you're going to get a half minus something. That's going to work out to be a half here. Then the half plus the half give you 1. So good. Question 4. So question 3 is usually fully trigonometry. And then question 4 is going to be a mix of like coordinate geometry and locus and stuff like that. Okay, question 4 says the equation of the circle and the straight line are given by x squared plus y squared minus 2x plus 2y plus 1 equals 0 and y is equal to x minus 3. Find the center and the radius of the circle. The shortcut method is to divide this part by -2 to find the center. Divide through by -2 to find the center. That's the shortcut method. So the center is 1 minus 2. But we don't take shortcut over here. Shortcut draw blood. So what we're going to do is complete the square. Completing the square of the x terms, we're going to get x minus 1 square. And then we subtract back 1 square. Completing the square of the y terms, we're going to get y squared plus 2y, so you half it. So you're getting y plus 1 square, and you subtract back 1 plus 1, and that's equal to 0. Then you put it in its standard form now, so you're going to get x minus 1 square, x minus 1 square plus y plus 1 square That's going to be equal to -1. -1 is -2. -2 plus 1 is -1. So when you bring it over, that's equal to 1. And you can always write 1 as 1 square. And so the center is 1 minus 1. And the radius is 1. So the radius is equal to 1. Nice and easy, 3 marks. Now it says show that 1 minus 2 is one of the points of intersection with this line. Now to show that it is a point of intersection, you don't need to solve this equation. What you need to do is, if 1 minus 2 is a point of intersection of the circle and the straight line, then that means it satisfies both the equation of the circle and the straight line. So to show it is a point of intersection, we can show that the point satisfies both the equation of the circle and the line. So without doing too much work, let's do that. So that means this point is 1, x is 1, and y is -2. So we're gonna let x be equal to -1 and y be equal to, x equal 1, sorry. Let x equal 1 and y equal to -2, and we're gonna sub into the circle. Plugging it into the circle, we're gonna get 1 minus 1 square plus, when y is -2, we get -2 plus 1 square. And when you check that, you realize that you get 1 minus 1 square is 0. And then -2 plus 1 square is +1. And 0 plus 1 equal 1. So hence, we can see that 1 minus 2 lies on the circle. 1 minus 2 lies on the circle. Let's sub it into the line now. Now, sub x equal 1 and y equal 2 into the line. So substitute it into the line now. Oh, this is -2. Sub it into the line. And so what we're going to get when we sub it in the line is -2 is equal to 1 minus 3. No, that is correct. Yes, it is true. And so we can see that 1 minus 2 lies also on the line. Hence, the line and the circle intersect at this point. All right, so no whole heap of calculation. We didn't need to solve the equation simultaneously. All right, waste of energy. All right, see, 6 marks to do that, and we didn't need to solve it simultaneously. So hence but let's look at method 2. Method 2 is if you're bored and you wanted to solve it. Method 2. Method 2 is just the typical calculation method, substitute into the line, into the curve. So you have, I'm going to use this equation, this one, the general form. You have x squared plus y squared minus 2x plus 2y plus 1 equals 0. Let's looking at method 2, x squared plus y squared minus 2x plus 2y plus 1 is equal to 0. Was that it? I think this was the right equation. Let's check back. Yep, we write it correct. And y is equal to x minus 3. So you substitute y equal x minus 3 in here. And so you're going to get x squared. Substituting y as x minus 3, this will become plus first term square, which is x squared, minus twice the product of 2 minus 6x, plus second term square, which is going to be plus 9 minus 2x, and then 2 times y will be 2x minus 6, so it will be plus 2x minus 6, then you have plus 1, and that's equal to 0. So what we did was substitute the line into the curve. Let's simplify this equation. X squared plus x squared is 2x squared. Then minus 6x minus 2x is minus 8x, plus 2x, that's minus 6x. All right, that's minus 6x. And then we have 9 minus 6 is 3, and 3 plus 1 is 4. This is equal to 0. And then we divide through by 2 to solve a regular quadratic. So we get x squared minus 3x plus 2 is equal to 0. And then you could factorize it. Equals 0. You're going to have x, 2, and 1. Signs are the same, but both of them negative, so you have minus and minus. So in this case, you're getting x equal 1, or in this case, you're getting x equal 2. You're getting x equal 1, or x is equal to 2. So you plug x equal 1 into y here, and so you're getting y is equal to, plug in x equal 1, 1 minus 3 is minus 2. And you plug x equal 2 in here, and you get 2 minus 3 is 2 minus 3, 2 minus 3 minus 1. So those are the points of intersection. So finally, you can conclude points of intersection are 1 minus 2 and 2 minus 1, and hence 1 minus 2 is a point. 1 minus 2 is a point, hence 1 minus 2 shown. Hence 1 minus 2 shown to be a intersecting point. All right, so that's how you do that with method 2. But I prefer method 1. Look at method 1, it's so easy. You just substitute this into the circle, substitute it into the line. It's going to satisfy both equations, and so it must be a point of intersection. All right, this says determine the equation of the tangent to the circle at 1 minus 2. Now, before I even do this, I just love to get a sketch of the circle. I always draw my sketch of the circle. And the reason why I do it is it gives me a rough estimate of what the equation of the tangent should be, even before I solve it. So the center of the circle is 1 minus 1, 1 minus 1, All right, this is not coming out so pretty. Just having a little glitch. So the center right here is 1 minus 1. That's the center of the circle. Center is 1 minus 1 right here. And then the point 1 minus 2, if this is 1, minus 2 is directly below it. So what do you think is going to happen? 1 minus 2 is directly below it, so the tangent must be like this. So we can clearly see that the gradient of the tangent is going to be 0. So the equation of the tangent is going to be y equals something. That's why I love my sketches. My sketches can just show me already. So this is clearly going, the equation of the tangent, even without solving it, I can tell that the equation of the tangent is y equal negative 2. That's the equation of the tangent without even solving it. The equation of the tangent is y equal negative 2. I can tell you that just by sketching it. All right, but let's do it by calculation. First thing we're going to do is find the gradient of the normal. The gradient of the normal is going to be rise. It has a rise, so it go minus 2 minus 1. Minus 2 minus 1 over x2, which is 1 minus 1. And so the gradient of the normal is undefined, or as we would say, infinity. But if the gradient of the normal is infinity, then the gradient of the tangent is minus 1 over infinity, and minus 1 over infinity is 0. The gradient of the tangent is 0. If the gradient of the tangent is 0, then the equation of the tangent is y minus the y value. So it's y minus minus 2, which is y plus 2, is equal to the gradient of the tangent, 0, into x minus 1. And so what you're going to get now is 0 times anything is 0. And so y is equal to negative 2. But just by sketching the circle, you could see what is going on. So it's very imperative that we sketch the circle always. Nice. All right, part B. Part B says let U be S3, S, and V be minus 2, 6, and 4. And it goes further to say, show that U and V are not parallel. So to show that U and V are not parallel, let me see. Show that U and V are not parallel. There are many ways we can show that they're not parallel. That's a lot of marks, 9 marks they want to show. But I can already tell they're not parallel just by looking at them. Because look at this. If they're parallel, going back to C-Sec mathematics, going back to C-Sec maths, I'm going to write it down. If two vectors are parallel, then one is a multiple of the next. If two vectors are parallel, then one is a multiple of the next. That's what we know. If two vectors are parallel, then one is a multiple of the next. So let's show that. Look at this now. And so that means that maybe vector v is equal to some constant times vector u. All right, that's what we know. So vector v, which is minus 2, 6, 4, that is equal to some constant k times vector u. But what is vector u? Vector u is S3S. All right. So what that means then is minus 2 is equal to k times s. Minus 2 is equal to k times s. We're getting that 6 is equal to 3 times k. And if 6 is equal to 3 times k, then what we're getting then is k is equal to 2. So from this, we're getting k equal 2. And finally, we're getting 4 is equal to k times s. Now, if 4 is equal to k times s, right, then over here, if k is 2, then that means that 4 is equal to 2 times 2s and 2 times 2s. So in this case, s is equal to 2, right? S is equal to 2. So if k is equal to 2 and s is equal to 2, let's plug it in here. So in the last one, we're going to do a check now. But look over here. Over here, if you plug in now, check in the first one. So we're going to check in the I component. We're going to check in I. So if you check in the I component, what you're going to notice is that if you plug in k as 2 and s as 2, you're getting minus 2 is equal to 2 times 2. But 2 times 2 is not minus 2. So this is false. This is not true. This is false. So this is false. So this is false. And so they cannot be a multiple of each other, and so hence they are not parallel. That's the easiest way to prove that they are not parallel. Nice and easy, soft. Of course, some persons would have mentioned if they're parallel, then we know that their dot product is going to be equal to the product of their modulus. You can show that u dot v should be equal to the modulus of u times the modulus of v for some particular values of s. But you're going to work out and see that for no value of s will the two modulus be equal. Stuff like that. So you could do that as well as an alternate proof, but I'm going to stick with this, the easy one. All right, so clearly they're not parallel. Soft. All right, it says now, determine the vector equation of a plane which passes through the point 1, 3, 0 and which is perpendicular to that vector. Again, I always like to draw to see what's happening. I have a plane, and they said that the plane has the point 1, 3, 0. So maybe this is the point. I'm going to label it as A. So maybe this is the point A. I'm just labeling it. This is the point A. And they said that it's perpendicular to this vector. I'm going to call this vector. I'm going to call this vector N. Right? Calling that vector N. You're going to see why soon. So if that vector N is perpendicular to the plane, then N acts as a normal to the plane. And so what that means then is R dot N is equal to A dot N, where N is the normal to the plane. And so the equation is going to be R dot N. N is 2, 4, 5. So it's R dot 2, 4, 5. That is equal to A dot N. And A dot N will be 1, 3, 0 dot N. And N is going to be 2, 1, 2, 4, 5. 2, 4, 5. So we work out this dot product now. 1 dot, that's now 2 plus, let me see, 1 times 2 is 2 plus 3 times 4 is 12. 12 plus 2 is 14. That's 14. R dot n is really 2x. This is 2x plus 4y plus 5z equal 14. But they didn't want this. This is a Cartesian equation. So always pay attention to what they ask. They ask for the vector equation. All right, they ask for the vector equation. So we're not going to write it in this form. This is the Cartesian equation. Cartesian equation. They want it in the vector equation. So the vector equation form, best way to leave it as is just the r dot. Some persons like to leave it as the column vector. You can leave it as r dot 2, 4, 5 is equal to 14. That's one vector equation. Or some people like to leave it as this. They are both still vector equation. R dot 2i plus 4j plus 5k. R dot 2i plus 4j plus 5k equal 14. Either way you leave it is fine. Because some people prefer the column vector form. Some people prefer the ijk form. So leave it as any one of these. And these are the vector equations. Alright. So anyways, up to you. Alright. Typically they usually ask to leave it in a Cartesian, but this time they said vector equation. This completes question 4.